The second part of the last property deals with the odd function. So if you have f as an odd function, then we know that f of negative x is the same as negative of f of x. And the property says that if you integrate it from negative a to a, the definite integral comes out to be 0. And again, the very first step to prove this is to split the integral. So if you have this integral negative a to a of f of x dx, you can split it in two parts, negative a to 0 f of x dx plus 0 to a f of x dx. And again, let's focus on the first part. What I'll claim is, I'll claim that this is equal to the negative of this. So when you prove that, the sum becomes 0, and that is what the property says. So what I need to prove is that this integral is the negative of this integral. So I'll start with this integral, negative a to 0 of f of x dx. And again, since we are dealing with odd functions, a very good substitution to make is u is equals to negative x, which gives you du is equals to negative dx. And when the lower limit was minus a, the new lower limit will become negative of minus a, which becomes positive a. If the lower upper limit was 0, the new upper limit will become 0 again. So if I replace all of these, my new lower limit is a, the new upper limit is 0, and this f of x again becomes f of negative u. This d of x is the same as negative du, so I can put a negative out front and a du over here. And now something interesting going on here, because what is f of negative u? Since f is an odd function, f of negative u is the same as negative of f of u. So what I can do is I can replace this with a negative of f of u, f of u. And something interesting going on here, negative times a negative gives you a positive, so that nullifies to give you integral from a to 0 of f of u du. And again, I'll use the old property that if you want to swap the limits of the integration, you put a negative sign. So this becomes a negative of 0 to a of f of u du. And again, I'll use the property that what is in the name. I can replace the u with an x, so f of x dx. And this is what I wanted to claim. This is the negative version of the other integral. So if I add these two integrals, I am bound to get 0. So the property has been proven.